Hello, this is the 3.1 classifying triangles objective. Um, got about 22 slides to go through here, but some of them go pretty quick. We're going to go right into it. Classifying triangles. We can classify by angles, and there are a few different ways to classify by angles. The first way is an acute triangle. Acute triangles are the triangles that have all three angles are acute, which means they're all less than 90 degrees. So if I were to make an acute triangle, it'd be one where all three of these angles would be less than 90 degrees. Now, if a specific example of an acute triangle is an equiangular triangle, that's where all three angles are congruent. Well, an equiangular triangle is the one where they're all the same, and in this case, they'd all be 60 degrees. Okay, we'd have 60-degree angles. Obtuse triangles, this is where you have one obtuse angle within your triangle. These triangles all look pretty wide, and if they're flat on the ground, like their base, like this is down here, we'd have one obtuse angle. This angle up here would be greater than 90, and then these two angles would be less than 90. But all you need is one, okay, just one obtuse angle to make it obtuse. In fact, it's actually impossible to have more than one obtuse angle. Okay, so we got our acute, our equiangular, and our obtuse triangles. The last one, the right triangles. This is where when you have one right angle. Okay, when you have one right angle and then two other, these would be acute angles. All right, that's our right triangle. All triangles, no matter how they look, if you were to add their angles together, they would add up to 180 degrees, which is why you can't have more than one obtuse angle, because if you take one obtuse triangle, that makes the last two triangles less than 90 degrees, and you can't have that. Same thing with the right triangles. You can't have a triangle with two right angles, because that would make them add up to 180, and then it'd be impossible for the sides to touch. Okay? You can also classify triangles by sides. The first one is a scalene triangle. That's where no sides are congruent. So here we've got three different side lengths. This is a scalene triangle. A lot of times we'll mark them with these hashes to show that they're not congruent. An isosceles triangle, that's when you have two sides are congruent. So if we had two sides congruent and a third that's not, this is an example of an isosceles triangle. And the last one, an equilateral triangle, that's when all sides are congruent. So if we'd have a triangle with all three sides congruent, now the nice thing is we've already had this triangle in our notes already. That was the equiangular triangle. Triangles that have all three sides congruent will also have all three angles congruent. So we can name them the equiangular equilateral triangle. Okay. Now we can classify these triangles just by looking at their side lengths. We have three different side lengths here, okay, which makes this our first example, the scalene triangle. Okay. We have two lengths of 12, one of 20. Well, there's two lengths that are the same. That's an isosceles triangle. Okay, looking at the angle measures, I see that we've got one angle that's obtuse, two that are acute. That makes this an obtuse triangle. Okay, we have one here, another obtuse angle. This one's also going to be obtuse. Okay. All right, I don't think there's a fifth one, but let me just double check. Yep. All right. So the symbolism that I was talking about earlier, we can use these hashes to show if sides are congruent. We can also use arcs. Okay, we use one arc. that shows that these are congruent. And if I show a double arc, that tells me that's not congruent with these other two. Same thing with the hashes, single hash congruent, double hash not congruent with the sides that are single. At any point in time, if you guys need to stop this video, if you're watching it on your own, please do so. If I'm showing this to you in class, I'll probably be stopping it a little bit along the way just to pace it a little better. So we look at the arcs that we're given here. We can determine what kind of triangles these are. Well, this one, all sides are congruent, all angles are congruent. All right, this is an equilateral, equiangular triangle. Okay, if we name it, classify with both, we can do so. This one over here, this looks like it is an isosceles, and looks like all three of these angles are less than 90 degrees, which makes it acute. Okay, so we can call this an acute isosceles triangle or an isosceles acute triangle. But again, we're classifying by side and by angle. If any triangle sides opposite, congruent sides are congruent, and angles, no, sorry, let me say that again. In any triangle, sides opposite congruent sides are congruent, and angles opposite congruent sides are congruent. Basically what this means is if I've got, I like to show it on the isosceles, I've got these two congruent angles, well, the sides directly opposite those angles are also going to be congruent. Nice thing with the equilateral equiangular, we got our three congruent angles. Well, all three sides that are opposite those congruent angles are going to be congruent sides. Okay, it always works out this way within triangles. How many right angles can there be in a triangle? Well, we talked about this. One. How many obtuse angles can there be in a triangle? One. Okay. I didn't show this before, but if I have an obtuse angle, there's no way I can make another obtuse angle. All right. In order to connect those sides, you're going to get two acute angles. Okay. So there can only be one. Okay. One obtuse angle and one right angle within triangles. Classify by both sides and angles. So we've got a triangle here, angle A, or triangle ABC. This fact right here, the fact that the three sides are not congruent, that equal sign with a line through it, that means not equal to or not congruent. All right, so these lengths are not equal to one another. That makes this a scalene triangle. All right, and the fact that we've got angle A is 40, angle B is 35. Well, let's figure out what angle C is. So if I add these together, I get 75. And if I do 180 minus 75, angle C is going to be 105 degrees, which makes this, because that angle is an obtuse angle, makes it an obtuse triangle. Okay, so sometimes you're only given two angles. You got to find that third angle to determine if it's going to be acute, obtuse, or right. But this fact down here is the one we were able to use for the scalene fact. Okay, here again, we've got our, none of the sides are the same, so we got another scalene. Let's see, 35 and 55. When I add these together, I get 90. Okay, well, if these are 90, I subtract 180 minus 90. I'm going to get angle P is also going to be 90. Well, that makes this a right triangle. So we got a right scalene triangle here for this example. If you guys are watching this on your own, this will be a good place if you want to pause at the beginning of each one of these and give them a try yourself. Or if you're studying for a test, to go back to these slides and pause it, try it yourself, and then you can see the answer I'm getting. Because there are questions just like this on the test. Triangle XYZ. Well, angle Y is 90. We know there can only be one 90-degree angle. That makes this a right triangle, and we're told that these two sides are equal. Okay, well, if those two sides are equal, that makes this isosceles. Okay, so it's a right isosceles triangle. All right, all we know are these facts. Okay, well, let's figure out what angle R is. Add those together, we get 130. That means our third angle, angle R, is going to be 50 degrees. Okay, now just like we know that when we have angles that are congruent, the sides across from them are not, the same works in this situation. If we have three different angle measures, that means we're going to have three different side lengths. Okay, so I know that the sides for this triangle are going to be different. So this is scalene. All right, now by angles, all three angles are less than 90, makes this acute. So it's an acute scalene triangle. All right, I think this might be the last one of these kind. Let's see, we got, all right, I like the facts like this. Two sides of the same length. It's isosceles. Okay. Angle E is 40 degrees. Let's see, how does that help us out? Can we classify it by, let's see, if I had a triangle with two sides that are the same, let's see, let's make this so it fits what we got. D, E, and nope, I didn't draw that right. Let's do this again. I need E to be the point in between the two congruent sides. Let's draw it like this. So here's my congruent sides. I got E in the middle. So DE and EF are the congruent sides. It says angle E is 40 degrees. All right. Well, I can actually figure out what these other two angles are because I know they're congruent. And I know they're congruent because these sides across from them are congruent. So if I do 180 minus 40, that gives me 140. So I know these two together have to be 140. Well, if I divide them by 2, that tells me each one of them is 70. So angle D and angle F are 70, and all three angles are acute. Makes it an acute triangle. So it's an acute isosceles triangle. Okay. Now, this is not really drawn to scale. This would probably look a little bit more like this. Okay. But drawing an isosceles triangle does help me get to that point where I know what it looks a little bit better. All right. Drawing triangles says draw a scalene acute triangle. A scalene acute triangle. So in this case, I would draw a triangle with all three angles acute and all three sides different lengths. So we'll go, let's see. The scalene one's always tough because I feel like I always end up making mine. But even if it's not, you're not sure, like these kind of close side lengths, go ahead and mark your sides like this. Okay. I know that all these angles are going to be acute. But just to show that the sides are not the same length, put different hash marks on each one. And isosceles obtuse, this one I'd make it a really wide angle up top, and the other side's about the same length. And I would show that by putting single hashes on those two sides. All right, here's some examples where we're solving for some side lengths or some angle measures. A lot of times we're just doing angle measures. It's a 90 degree, even though it doesn't say it, that's a 90 degree angle. And it's isosceles. We've got single hash marks here. That means that this angle and this angle, angle 1 and 2, are congruent. So if I do 180 minus 90, I get 90. And these two angles added together have to equal 90, so I divide them in half. angle 1 equals 45 degrees, and angle 2 equals 45 degrees. Okay, they're both 45. This is actually one of those, if you have an isosceles right triangle, the two acute angles will always equal 45 degrees. Okay, always, no matter how big, right, or small you draw it, okay, these acute angles will always be 45 degrees. And that's because if you have a 90-degree angle, when you take that away from 180, you always have 90 degrees, and then half of that is 45. All right. Sorry, this one's a little bit harder to see here. I think that's actually an A over there. Let's see if we can figure out these angle measures. Let me see if I can or not. Okay, yep, we can do this. So that is A. So here's what we're going to do. Let's try and figure out some angle measures. Now, the easiest one for me to look at first is B. Okay, so we're going to figure out what A, B, C, and D equals. So I'm going to figure out B first because I know we have this right angle up here. And I know this right part of it is 32 degrees. So if I do 90 minus 32, right, I get 58. Well, B is going to be 58 degrees. Once I know that measure, I then take a look at this triangle over here on the left. I know that triangles have to add up to 180, so I've got 58 and 55. If I add those together, I get 113. I subtract 113 from 180. All right, and I get 67. Well, that 67, that's what goes with angle A. Okay. Now let's look at these other parts. I think the next one I need to figure out is C. And what I'm going to use here is the 67-degree angle that we have for A. I'm going to 67 plus, so I'm now looking at the big triangle. Let's see, let's go to a different color. Let's go blue. So now I'm looking at the big triangle. Okay, I've got my 67-degree angle over here. I've got a 90-degree angle up top. When I add them together, I get 157. If I do 180 minus 157, what's left should be C. That's 23. So C is 23 degrees. Now, one more shift. We're going to look at just this triangle here on the right. We're going to make it green. I know two of the angles, 32 and 23. Add them together, we get 55. If I do 180 minus 55, what was that, 125? That 125 is our D angle. Okay, so we're able to find A, B, C, and D. We just got to work our way around. We found B because we knew it was a complementary angle with the 90-degree angle up top. So 32 and 58 together gave us 90. So that's where we found B. We then looked at the red triangle on the left because we knew two of the angles, 58 and 55, added them together and subtracted them from 180, all right, to get 67. Then we looked at the big triangle. We knew the top angle and the left angle, added them together to get 157. Subtract from 180, we got 23. And then we looked lastly at the green triangle. Same idea, added 32 and 23. Got 55, subtracted that from 180, and got 125. Okay. Last one. Okay. We know that a property of triangles is all the angles add up to 180. Okay. So if I take these three expressions, add them together, 2x plus 4 plus 2x minus 9 plus x. I know if I add them together, they should equal 180. Well, we have an expression with one variable. We can solve for x. Combine my like terms. 2x plus 2x plus x. That's 5x. 4 minus 9 is negative 5. I'm going to add 5 to both sides. And I'm going to divide both sides by 5. Let's see. We'll get x equals, let's see, 5 goes into 185. Is that 37 times? I got to double check. 37 times 5. Let's see if that equals 185. 5, 3. Yep, 185. All right, x equals 37.